In this section we want to talk about application details. This script is going to show you the application short name, Oracle user ID and Oracle user name, status of the application, if it is fully installed, it is inactive, or it is shared. What is the version of the module? Is it 11i, 11.2.10.0.0? This is going to show you the base version, and it is also going to show you the table space for data as well as for the index for a given application. So if you want to find out what is the table space for, say, GL, or AR or AP or PA or PO in this case, or let's pick some active one. Click on the status. So FND, for FND you can see the table space is same as all the other table spaces. Why is that? If you have been working in ERP for a long time, in 10.7 Smart Client or 10.7 NCA, Network Computing Architecture, or 11.0 ICA, Internet Computing Architecture, or 11i, initially in these modules, each module or each application will have its own data table space as well as its own index table space. And we had fewer modules, and we had like 50 modules, 70 modules. When they were adding more and more modules, we were seeing that we ended up having 400 different types of table spaces, including index and the data table space. So for each module, for example GL, you will have GL table space for data and GL table space for index. Then you will have, for PA, for example, project accounting, you will have a table space for data for project accounting, and same thing for index. So each of these objects which are specific to a module, they were using their own application specific table spaces. So you had 200 modules, you will have 400 table spaces. For each 200 module, you will have one table space for data and one for index. Data will store all the tables, index will store all the indexes on these tables. So when RAG came into picture, we were running out of ways to accommodate the raw devices based file maps. So we had a limitation on number of raw devices you can have, and so Oracle started to think and say we have to redesign this whole architecture. And in modern storage systems, since the storage systems are doing all the RAID based slicing and dicing of the table spaces and the files, which are data files underneath these table spaces, there was no reason for us to distribute the data the old way. In olden times, we had 20 mount points in Unix, U01, U02, U03, all the directory structures, right? And they are coming from different mount points. They're coming from different devices. So, and those devices are made of on, say, 20 drives. So U01, 20 drives, U02, 20 drives. I'm just giving an example. U03, next 20 drives. So first 20 drives, U01. Next 20 drives, different drives, U02. Next 20 drives, different drives from the above 40 drives was U03. And we would manually place the hot table spaces, hot tables in different mount points to do a physical or a manual I/O distribution. If you have seen our deep dive I/O courses, we don't need to do that anymore, because underneath that, I recommend you go and look into our advanced Linux videos. We talk about all details about I/O travel paths and devices and logical and physical LUNs and all these things. And if you'll watch the deep dive I/O course, you will also get in much more depth. So in modern systems, behind the scenes, for example EMC, they create meta devices out of physical devices, and then they do vertical, horizontal striping. So each file of 1 gig is chopped into 128 kilobytes or 1 megabytes or 4 megabytes, depending on how much stripe width and the stripe size you need. So each chunk was already chunked into smaller pieces, right? It was done by the EMC storage before it was presented as a mount point to the applications. So there was no need to go to this route of having each and every table space holding application specific indexes and tables. It was not required to go that way, right? So because of all that stuff, Oracle came with OATM model, Oracle Application Table Space Model. Fancy name. All they are doing in the Perl script is moving the table objects and index segments using alter table move commands and alter table segment, index segment move commands, maybe rebuilding the indexes underneath it, and moving the segments and extents from various 400 table spaces into shared 7-8 table spaces. In this example, you can see there's only 2 table spaces here for all the application, one for index, one for data. And each table space will have maybe 20, 30, 40 different data files, 10 gig each, 20 gig each, and each 20, 30 gig, 10 gig file will be chopped into 1 megabytes of small pieces and spread across all the spindles behind the scene. So going to OATM model reduced the problems which people were facing, because in a raw device each data file has to be mapped to a device and you have to do all these things. This is before ASM came into picture, right? So Oracle came with the ASM, you're getting the same raw device IO, direct IO speed as a raw device, but you're having this abstract layer called ASM layer, which is doing all the file block management, hot block management. Oracle has extents which they are managing in the ASM instance in memory. So this extent map is mapping the whole map of all the data files. And ASM, we have done a lot of work on ASM, covered a lot of things in ASM videos, so watch those videos under rack and you can see how to design ASM, how many LUNs you need for ASM, under a group, how many groups you need, what do we suggest in terms of 64-way stripe, 16-way stripe, why do we recommend that. So what I'm trying to tell you here is, in olden times these were physically done by apps DBAs and DBAs. They have to monitor the IO read and write rate, millisecond response times. Watch our deep dive IO, you'll get much more in-depth discussion on that. So this manual activity done by DBAs and apps DBAs does not need to happen right now, because hardware systems take care of it, unless you are in a low-end array which doesn't have caching, which doesn't have all these features. So by going to a single table space model, and then if you're going to rack, going to ASM, and now they have ACFS also in 11gr2. So you are letting Oracle ASM manage your hot blocks. EMC does it, Hitachi does it. So when they are managing their extent, they also know which extent you're hitting. What is a extent? That is separate extent from Oracle extent. You should watch my advanced Linux video to get the detailed explanation on that. But so they also can detect hot blocks, and they will quietly move the blocks around all the devices, right? They will try to eliminate the hot blocks. Same thing, Oracle will know how many LUNs does it have. Now each LUN presented to ASM is already having the chopping of the disk done already. So you are maybe giving RAID 10 or RAID 5 in 16-way stripe data already with hundreds of spindles behind it already to the LUN which is presented to ASM. Now ASM will also restripe it on top of these LUNs which are already been striped properly by EMC or Hitachi, right? So ASM will look at these LUNs 1 to 10. It doesn't know what is behind under the LUNs. It doesn't know it is RAID 10 or 5. It doesn't care. It will see these devices as unique disk, and it will implement striping on top of these LUNs, and it will distribute the file across all these LUNs. It loves to do 64-way striping because this is how internal algorithm is tuned for as far as ASM is concerned. So we recommend something for data, for flashback, for temporary table spaces, redo, and all these things. There's a coarse striping, fine gray striping, so Oracle does all these things for you. You can get all the details from different videos. So to overcome the initial problems of having so many table spaces, Oracle came with this OATM tablespace model, where they are eliminating all the table spaces specific to modules, and they have a shared tablespace model. This is the history, this is the logic, and we don't need to do this, as I said, manual IO distribution. The high-end system does it, Oracle ASM does it, so there's no need to have so many data files to be managed individually and moved into different LUNs or mount points. We don't need that anymore. Alright, so this is where you see, don't be confused, this is the history and logic behind it. That's why you see every application, every module is having this shared table spaces. Where is it coming from? The data is coming from FND Oracle User ID, FND Application, FND Product Installations. So I'm combining these three tables and I'm getting the data into this report.